In this lesson we are going to describe the three groups of engine indications and their purpose. We start by introducing you to the three engine indication systems, and then we explain what they are used for. Engine indications are used to monitor the parameters of the engine and its systems. The engine indications can be divided into three groups. First, there are the performance indications that are also named primary indications. Then there are the system indications that are also called secondary indications. The third group of indications is used for engine trend monitoring and is usually not shown in the cockpit. Now try this task for a brief introduction to each group of indications. The performance indications are used to monitor the performance and the limits of the engine and to set the thrust for the different flight phases. The system indications are used to monitor the operation of engine systems such as the oil or fuel system. They are also used to detect malfunctions quickly. Engine trend monitoring is done on the ground to detect engine problems at an early stage. It uses engine parameters that are automatically recorded by the Aircraft Condition Monitoring System, ACMS in short. There are engine indications such as the ones shown on this ECAM display system. They have a combination of gauge-type analog displays and digital readouts. There are also analog indications with moving vertical bars, such as the ones shown on this ICAS display. Now try this question. This segment looks at general aspects of the primary engine indications. You will learn the details of the subject in later lessons. The indication which is always located at the top is used to monitor and set the engine thrust. Because it is not possible to measure the thrust directly, there are two different indications which give an equivalent value. This is either the rotational speed of the fan, called N1, or the engine pressure ratio. The other performance indications are the engine rotor speed indications for each rotor system. This means that in addition to N1, there is N2, and if available, also N3. There is also the exhaust gas temperature indication, EGT, and the fuel flow indication. Now try to find the answer to the question about this set of performance indicators from an older aircraft type. Data for the indications is gathered by specific sensors or probes. The data is usually electrically transmitted to the indicators. You will learn about the sensors and probes in more detail in a later lesson. Sensors fitted to engines with a FADEC system will first transmit the data to the FADEC system computer. The computer then sends the data to the indicators or display system and also uses it to control the engine. In the next segment we look at the secondary indications. We use the secondary engine indications to monitor the correct operation of engine systems. These are also called engine system indications. You can now find out what these indications show by carrying out this task. the indications on the ICAS generally give the same information as the indications on the ECAM, although they are shown in a different way. It should not be too difficult for you to find the oil temperature indication on this display. There are also warnings and cautions displayed on the ECAM or ICAS page when an indication exceeds a limit, or when, as shown here, the system detects a low oil pressure, or when a filter gets clogged as indicated here, or when an unlocked thrust reverser is detected. You will learn about these normal and abnormal indications in more detail in the relevant units. For example, the oil system indications will be shown in the oil system lesson in Unit 79. In the next segment, we will look at trend monitoring. Modern engines are very reliable and economical, but the performance of the engine modules decreases during their lifetime. To prevent larger performance reductions or even engine problems during flight, you need a monitoring tool that alerts us to a problem at an early stage. This tool is called engine trend monitoring. The engine trend monitoring is done in the workshop by analyzing engine data that is periodically recorded during flight by the Aircraft Condition Monitoring System. The ACMS provides this data on a printout from the cockpit printer, and it can also usually transmit the data via the ACARS data link to the ground. The transmitted engine data is analyzed by a computer system in order to find any parameters that indicate a trend towards a limit. 3 different analyses are usually done: the thermodynamic analysis, the mechanic dynamic analysis, and the oil consumption analysis. You can find out more about these analyses from the engine trend monitoring options shown here. The thermodynamic analysis checks the pressures and temperatures along the gas flow path. It also monitors the feedback signals from the VSV and VBV, the active clearance control, and the fuel flow. The data gives exact information about the condition of the engine components involved in the thermodynamic process. The mechanic dynamic analysis mainly checks for failures in the rotor system, for example, imbalances and bearing failures. To do this, it checks engine vibration and rotor speed signals. The oil consumption analysis generates an alert when the oil consumption exceeds a certain level.